I'm Tim Campbell, Purkeys product manager. Been with Purkeys around 3 years, 2.5, 3 years now. And we also have Jimmy Fielding, certainly my senior at Purkeys. Jimmy, how long have you been with Purkeys?
26 years now. So yeah, Jimmy Fielding, sales application engineer. Been here a few years, so yeah. Kind of started building, when we first started out building starters and alternators, and just kind of moved my way up. So
so a lot of this stuff, Jimmy's been there, done that, or been involved with the product all the way from the ground up. So excellent resources, and again, Purkeys has a fantastic team. If anyone needs anything, feel free to reach out during the webinar. There's question and answer, or after as well. But without further ado, let's jump into Liftgate charging system maintenance and diagnosis. So to start, quickly before jumping in too deep, is if you have a test light, it's not going to do you much good for Liftgate charging system diagnostics. You really do need to have a voltmeter handy. Bonus points if you have a clamp-on amp meter for a lot of the diagnosis as well. But end of the day, a test light is not going to tell you much about what you need to know. We also have a fantastic, some of you may have already seen it, but a fantastic multimeter basics webinar. I believe that's in the resource list. And also after that webinar is a really good test to test your knowledge on a multimeter. Sometimes some of the questions even get me. So it's a great test to take.
And just to add to the whole test light thing, Tim, is it takes milliamps to light that little LED that's inside that test light. So it does have its purpose. It does have a pretty sharp point on the end, so you tend to pierce wires, and you start inviting all that corrosion in. So it does have a purpose, but really just, do you have a completed circuit is all it's going to tell you.
Yeah, exactly. Thanks, Jimmy. Jumping in here, this is something that chances are everyone on this webinar has seen somewhere in their fleet. This is the Purkeys lineup of Liftgate charging systems. You'll see some of the, I guess we'll call them some of the older systems up there in the top right. The old style direct and select, where it would have the external receptacles for those. And of course, the newer style down at the bottom, ones that you might be more familiar with in your fleet. And end of the day, we'll touch lightly on all of these. But again, if you do need specific information on any of these systems, reach out to us. We're happy to send documentation, walk through the systems over the phone, or even go out on site and help do some training for you and your technicians. We'll get into what differentiates these systems a little bit more, but end of the day, the logic behind all of them remains fairly consistent. One other thing to touch on is back inside of your Liftgate battery box, there is the DC-DC charger. That's going to be the voltage booster to boost that source voltage, whether it's coming from a Stinger cable, 7-way if it's spec'd for that, or even reefer charging. This is going to boost that voltage up. We'll talk about that a little bit later in this webinar, but a thing to note is the two different styles here. On the left is the older system that has that 4-pin Deutsch connector going into the charger itself. The new style on the right just has the flying leads coming off of it and going to those junction blocks on that charge plate assembly. Again, we'll touch on that a little bit further into the webinar, but just wanted to get this in everyone's minds of the different systems that are out there.
The charging plate footprint is all the same. So, if you had an old style and you were shipped a replacement new style, it all fits the same. So nothing changed on the back plate.
Yeah, that's a great note there. And really even, I'll back up a quick slide here. Just about all of these systems will be utilizing the same or very similar wiring harnesses, specifically between this nose box or the front of the trailer and going back to the charge plate assembly. Throughout the years, not much has changed as far as the wiring. So upgrading systems or changing systems is something that can be done in the field if you have some older trailers that you're looking to upgrade to newer systems. Let's talk about how the system works. So as we mentioned, a lot of them have pretty similar logic. And right here would be the select system. Select being that it can select from different charging sources. So those of you that have the select system, this won't be too much news to you, but it does have up to the 3 charging sources. Of course, you have your stinger cable itself, so that's either your single or dual pole, and it has those sockets integrated into the nose box. It could also come spec'd with a 7-way charging, so it would have an external harness going to your 7-way receptacle. That way, if the driver forgets to plug in that stinger cord, or happens quite often where that cable isn't managed correctly, the stinger cord could short out on the catwalk. You lose your dual pole charging. That 7-way can pick up the slack there. And of course, in the bottom left, you also see the reefer, which can be utilized for liftgate battery charging as well. So it's really giving you your best line of defense for keeping those batteries charged by having all of those sources. Something that we do get a lot of calls on is, and we'll talk about it a little more in depth later in the webinar, but that the system isn't charging. Well, one thing to keep in mind is that our system will not turn on unless it sees 13.2 volts minimum from either of these 3 sources. If you have a running tractor that has charging system issues and it's only outputting 13 volts, our system's not going to turn on. It doesn't quite see a high enough voltage to justify charging. It doesn't want to pull off a tractor that isn't running. It doesn't want to start charging from something that's been turned off. Yeah. Up top, of course, the LED indicators, and that's something to keep in mind as well. All of our systems do have a decal on the side that shows what those lights in the LED logic are. You'll see flashing green, flashing orange, solid green, even white on the nose box styles for interior lights. And the nose box is going to be what actually controls that charger in the battery box. So without this nose box telling that charger to turn on, that charger in the battery box will sit there all day. The logic to turn that charger on and off happens up at the nose box. And as we mentioned, go ahead, Jimmy.
Yeah, without the logic in that control box, it could pull, power from that power source all the way down to, close to 10 volts, which is, we all know what happens when we start reaching those voltages. You're going to risk, tractor not starting or reefer not starting. So again, it's all to keep logic is there to keep a balanced system. So we're not jeopardizing our power source to charge liftgate batteries.
Yeah, and that's an important point. We have seen some people in the field making some modifications to the system, whether it's a road call or someone that doesn't feel that the system's operating correctly, where they will try to bypass that logic in the nose box and keep that charger running 24/7 back inside of the battery box. And that's a very quick way to deplete your charging source and kill the tractor battery or the reefer battery. It's a good thing to know how to do as far as a diagnosis of maybe jumping some of the wires to see if individual components are operating correctly. But end of the day, like Jimmy was saying, the logic inside the nose box is extremely important in determining when to turn that charger on and off. And of course, like we mentioned, that DC-DC charger all the way on the right side of the screen, purpose is to take whatever input voltage is sent to it, boost that voltage up so that those batteries can get a healthy charge. Jumping from the select to the direct nose box has a lot of the same logic, but it's only going to be a single source charge, where before you could charge, you could look at the 7-way, your reefer, and the stinger cord itself. The direct is just going to be a one source charging system. We have some fleets spec it differently depending on what they're looking for. The most common would be a direct charging system that only has a stinger cable, so your single or dual pole cable. But we also have some fleets that they just want to charge strictly through the 7-way. It's usually not the best source of charging compared to the single or dual pole cable, but it's still something that's offered and does work for specific fleets. Again, a lot of this depends on your fleet's usage and what that use case looks like. And of course, we also have straight truck applications where it would more or less be hardwired into the vehicle's starting and charging system, but still offer the protections to those auxiliary batteries, ensuring that they stay charged, but also protect the starting batteries from running down too far and having a no start issue. One of the benefits on all of the Purkeys charging systems is an extended charge function. So the logic inside of the nose box is always looking for voltage thresholds. The entire time that it's sitting there, it's looking at those input voltages, whether it's from the stinger cable, reefer, 7-way, however your fleet is spec'd with the Purkeys system. It's looking, as we mentioned before, looking for at least 13.2 volts before it's ever going to pull from any charging source. That's what it uses to assume that that charging source has a running engine. And once it does begin pulling from that charging source, it will continue to charge even after the engine is shut off, assuming that it's still powered. Sometimes you get into situations with 7-way charging, it's ignition switched, it's not going to continue charging there. But say it's connected with a stinger cable or connected directly to the reefer, engine shuts off. Once our system sees that voltage drop below 12.8 volts, it's going to begin a voltage, they call it the extended charge mode, and it's going to begin monitoring that voltage a bit more closely, and specifically on these nose box units, really starting to start a 60-minute timer. If it's in extend mode for more than 60 minutes, it shuts off, but it is still giving those liftgate batteries an extra hour of charge time. And of course, you see the bottom of the chart there. If it drops below 12.4 volts as a resting voltage on that battery that it was charging from, it will also stop the charging there, just to ensure that that starting battery has enough power to start that engine back up.
Yeah, whichever comes first.
Correct.
Yeah, if it drops below 12.4 within, before that 60 minutes, we're definitely going to shut off right at that point.
Yeah, prioritizing engine starting batteries is always at the heart of any of the Purkeys logic. We want to make sure that whatever engine it's charging from still has the capacity to start back up. That way we can continue charging off of it once it restarts. And of course, kind of oversimplifying it here, but we talked about the extend charge. This is really where that DC-DC charger shines brightest. Is, well, you look at the chart on the left, say that the source is only 12.5 volts coming into the nose box. That's fine, but you're really never going to get a healthy charge back at those liftgate batteries with 12.5 volts, especially once you run the length of the cable going from the front of the trailer all the way back to the battery box. That voltage can drop significantly, specifically when it's under load, like charging. This is really where the DC-DC charger puts in its work. You get your money's worth out of it, and it boosts that voltage up to a healthy charging voltage so that you can keep those batteries topped off and in a good state of charge. And next up, hope everyone's ready, our first poll question. And here we go. I hope you were paying attention in the last 30 seconds because the answer was in there. What does the extend charge feature of the Purkeys liftgate charging system do? You have A, it continues charging after reefer or tractor engine are shut down. B, allows the liftgate batteries to continue to charge during stops. C, provides additional opportunity charging to the liftgate batteries. Or of course you have D, all of the above. We'll see who's been paying attention for the Purkeys extended charge feature.
Give me a few seconds to answer, and we'll look at the results. Looks like we have, now they're starting to come in, 7 out of 20 submitted. See if we can get a few more before we move forward.
Yep, the extend charge really is a really fantastic feature of the system, and it's something that you always have to be careful of with the 7-way charging, mostly because of that ignition switched power on the 7-way. But it's a fantastic thing to keep in mind with the system. And at this point, wow, we have a really good response right here. Let's see how we did. Hey, all right, not bad. Yes, the answer was all of the above. So really, technically, any of the above answers were correct, but also more importantly, all of the above answers were correct. The extended charge feature really does give a added boost to those liftgate batteries when that engine's not running, and just keeps that charge going. And from here, I think time to hand it over to Jimmy. Jimmy, do you want to jump into the troubleshooting and technical issues?
Yeah, thank you so much, Tim. Great overview of the system and how it works. So I'm gonna kind of dive into, gonna get a little technical. I'm gonna kind of cover some of the common technical issues and how to troubleshoot them. Provide you some quick diagnostics. Of course, there's other things that could happen that you have to kind of dive a little bit deeper, but some of the most common ones are listed here. So common technical issues are no LEDs on the front controller. And that's those LED indicators are really there for the driver, or even the technicians, or the person walking the yard, just looking to see what the current state of the liftgate batteries are, or even the source where we're pulling that power from. So no LEDs. The second one is obviously it's not charging the liftgate batteries. So I'm going to kind of go into a little step-by-step, kind of the quick diagnostic. So we'll start with the no LED scenario. So all these controllers, they got to get power somewhere to power them on and provide your LEDs. And that's going to be from your liftgate batteries. Now, on some of the, or actually all of the new design where you have the receptacles built into the controller, those can be powered off, either the truck or reefer, whereas the older designs where you tie into the existing receptacles that are on the trailer, those have to be powered by the liftgate batteries. So we're going to kind of start with our power source for powering the module, which is the liftgate batteries. So are we getting power from the liftgate batteries? And you really need to start right at the batteries. Make sure you have good voltage, and typically 6 to 7 volts. If you're seeing that low of voltage on the batteries, that's probably why you don't have LEDs up in front. Most electronics need to at least have 6 to 7 volts to even turn on. So that might be your stopping point. If it's that low, then you either need to charge those batteries or replace them. But once it, the circuit leaves those batteries, it goes through a 30 amp breaker. And you want to make sure that breaker is not tripped. There's a little yellow arm on that breaker. If that little yellow arm is flipped out, that's likely the reason why you don't have LEDs, because that circuit's not complete. But more importantly, do an inspection before you just assume that was the fix. Obviously, that breaker tripped for a reason, so make sure there's nothing shorted out. You can check voltage on both sides of that breaker at the back. There's 2 studs where the wires connect on the back, and just make sure you have voltage on both sides of that breaker. Make sure that bracket is securely mounted. If it's falling off the roof of that battery box and laying on the batteries, probably not good. It could possibly cause a short and more damage. And again, inspect the wires on the back of the breaker. Next thing is you want to move from that 30 amp breaker to the charging plate assembly. And where that 30 amp breaker connects to is this red stud that's right above the DC-DC converter. From that red stud, it goes through a fuse holder. It's kind of hard to see because it's behind this 4-pin plug, but there's a 2 amp fuse to protect that circuit before it gets to the control module up front. And really why we put that 2 amp fuse in there is, you know, installers, they got a lot going on. They're making connections, and we just put that in there to kind of protect the control module up front if they were to, you know, touch something to ground or short something out. So yeah, make sure your 2 amp fuse is not blown. If it's not blown, then kind of move on to the next step. The key is you're kind of working your way from the liftgate batteries through the circuit on the charging plate, and then all the way up to the front where that connection is on the controller. So with your voltmeter, set your voltmeter to DC volts. Measure the voltage on the orange wire. So you see in this picture, that 2 amp fuse connects to this 2-stud strip, and you want to make sure you have liftgate battery voltage on that orange wire at this connection point. If you do have voltage, if you don't have voltage there, then you know the previous steps, there was either a trip breaker or blown fuse. But more importantly, when you're at this point, and what we've seen a lot is the installer has to route this. You see these 4 wires here. It's all in a jacketed 4-conductor harness. It's typically, you know, anywhere from 30 to 50 foot long. We don't make these connections. We leave these bare so the installer can make the connections, and they can, you know, cut the wire to length, and that way you don't end up with a bunch of coiled up harness at the battery box. But if they strip that sheathing off to access these 4 wires, we've seen it where they've actually cut into and nicked some of the wires, and, you know, didn't properly cover that section with heat shrink, which is included in all of our kits. So water starts coming in and corrodes out the wires. When you're at this point, really do a good inspection of where that sheathing was stripped off. You may be going down a rabbit hole once you move to the front, when the problem is right there at that point. So moving forward to the next step, and I'm going to show a few examples of the different control modules that we have. This one is the direct, where it ties into existing nose boxes on the front of the trailer. So now that we've moved from the liftgate battery box, we're going to move up to the front of the trailer and measure that same orange wire that is powering up this control module. And this is just an example on the direct system. So again, set your meter to DC volts and just simply measure the voltage on that orange wire. That voltage must be above that 6 volt range. If it's not, then you must have an issue with that orange wire. That's typically the fun part to figure out where that break is in that circuit. But if you put a lot of focus where they strip that sheathing off, that's where I would start first. If it's not there, then it's somewhere along that 50 foot of cable. Same exact thing on the select system, and this is the select system that multiple source charging, but ties into the existing nose boxes, the existing 7-way or the existing dual pole or single pole nose box. It's got that same orange wire, so you're going to check voltage with your voltmeter on that same orange wire. Make sure you do have voltage above 6 to 7 volts. this same thing. This is just an example of this on a select or direct system that has the built-in receptacles. And all of these diagrams and stuff are all in the resources that will be available to you. This is just showing the Plus, Flex, and Max family. The Plus, Flex, and Max family just has a built-in 7-way. All the logic is all the same. But we're just showing you where to check that orange wire for voltage. So kind of moving on to the next common scenario is just simply not charging the liftgate batteries. So first thing you want to do is connect the tractor to a trailer via the whatever charging source you have, whether that's the dual pole, the 7-way, or you can even do it off the reefer. But simply start that tractor and observe the LEDs on the controller. What you want to see, again, Tim talked about those voltage thresholds earlier. We must see at least that 13.2 volts to even start the sequence. And what happens is, once we reach that voltage threshold, the source LED, whether that's source, dual pole, single pole, reefer, or the aux circuit of the 7-way, should go solid green. At that point, we tell the DC-DC converter it's okay to turn on now. So what you should also see is a solid green LED on the lift battery. And in order for that lift battery LED to go solid green, we must see a voltage on those liftgate batteries at about 12.8 volts. We put that threshold in there because at that voltage, you must be charging those batteries. So we didn't want to give you a false positive and just, if we're solid green on source, we didn't want to give you a false positive and just automatically turn that LED solid green. We wait till a certain voltage threshold to do that. So if you have LED logic sheet, if no, we have in your resources, we have a LED and logic cheat sheet. It really kind of walks you through all the different scenarios as far as the LEDs. But the key message to this slide is anything blinking, any LEDs that are blinking, you're not charging. It is only giving you a current state of what your source is sitting at and your liftgate batteries. So say I'm blinking green on my source. That's just saying, my tractor is above 12.4 volts, or my liftgate batteries are above 12.4. If you get the blinking amber light, it's below that threshold. Solid green is the only one that's indicating that charging is occurring. So kind of some quick diagnostics for this, with a voltmeter set to DC volts, measure the voltage on the black wire. So the black wire is going to be your input wire, and your white wire is going to be the ground. It should read approximately tractor battery voltage. And this just shows all the examples of where to check that voltage. If yes, proceed to the next step. If no, check the 30-amp fuse for that source, whether it's the Stinger or the aux. And I'm pointing out these fuses inside these boxes. Some of the older style selects have what's called a maxi fuse. It's a big 30-amp fuse. And we've kind of, over the years, we've moved into a bolt-in style fuse. Just provides a better connection point, but it's what's called a 30-amp MIDI fuse, MIDI fuse. So you have to check those fuses and make sure they're not blown. And then move on to the next step. If the fuse is not blown, typically a rapid flashing orange indicates a blown fuse. So if you're getting a rapid flashing on your source. Typically, you want to look at these fuses inside this box. If you're getting a rapid flashing amber or orange on the lift battery, not always, but typically that's a grounding issue on the pump motor box. I get asked the question a lot is, why do we fuse the ground circuit? And the reason being is, if those pump motors aren't properly grounded, it's going to find a path somewhere. And typically that's through our 50 foot of harness. So versus burning up 50 foot of harness, we'll blow a fuse for you. So if it is flashing rapid orange or amber, don't just replace the fuse. Really dig into, see why the, look at the pump motors, make sure they're properly grounded, make sure your batteries are grounded to the frame of the trailer, and that will likely fix that problem. So kind of continuing on, test the black input wire and the white ground. This is just same thing, just showing an example on the Plus, Flex, and Max system, and where to check these voltages inside the nose box. The next thing you want to do is, if it's not charging, you want to look at the ignition wire. It's the yellow wire. I like to think of it as the on and off wire. When we have all the right voltages up, from our power source, that's how we signal that DC-DC converter in the liftgate battery box to turn on. So, with your voltmeter, measure the voltage on the yellow ignition wire and the white ground wire. It should read anywhere from 10 to 13 volts. If yes, move forward. If no, inspect that yellow wire and make sure all the connections are tight. Make sure it's in the right spot. I've seen where a trailer went through a road call and they didn't know where things went. They put the yellow wire on the wrong spot, so the system didn't work for that reason. So look at your diagrams and make sure that yellow wire is in the correct spot. And make sure all the connections are good. This, again, just an example showing with the Plus, Flex, Max family where that yellow wire is. And then measuring at the 4-pin plug. If you have the older style DC-DC converter, you can actually unplug the plug and measure at that 4-pin plug. So with your voltmeter, measure voltage on pin number 1, which is your input, and the negative lead on pin number 3, which is your ground. Now that should read tractor voltage. If yes, proceed to the next step. If no, the issue is between the 4-pin plug and the select controller. So you'll need to replace that circuit. Now move over to the, with the voltmeter set to volts, place negative lead on pin number 3, which is your ground, and positive lead on pin number 4, which is your ignition. If you have it up front, you want to make sure you have it at the DC-DC converter, because again, that's what's telling that converter to turn on. So if you have voltage, if yes, proceed to the next step. If no, again, that issue is in your yellow wire. Either it's a break in that circuit or loose connection. I've even seen where there was too much heat shrink put on the ring terminal when it was tightened down on the stud, and that was causing the break in that circuit. Just simply too much heat shrink over the eyelet, and it was causing it to make and break contact. So again, still back at the 4-pin plug, place a negative lead on pin number 3, and positive lead on pin 2 should read liftgate battery voltage. So we're making sure we get we have a good path to the liftgate batteries. If no, reset the 30 amp breaker, which we talked about that earlier, or inspect that circuit. At that point, you've kind of done everything. If you've done all this and it's still not working, the only thing left is the DC-DC converter. But don't automatically go to, say, hey, the DC-DC converter is bad. Do these simple checks before you do that. Okay, so that was kind of long-winded, but again, those were some of the real simple checks, the common things that happen. And really, it's just start the batteries and kind of work your way forward. So we're going to go into a poll question, our next poll question. So what is the most important tool to have when diagnosing a liftgate charging system? So should I have a voltmeter, a test light, clip-on ammeter, or an oscilloscope? Give you a few seconds. Looks like we got some participation here. We got quite a few coming in now. All right, we'll kind of move forward then. Let's see what we got here. 100%. Yeah, voltmeter is really key, and clip-on ammeter is a bonus, especially with liftgate charging systems. If you got all these LEDs that are supposed to be telling you what's going on, if something were to happen to an LED or something like that, if you had a clip-on ammeter, you could show without a shadow of a doubt that it's charging because current's flowing. But number one, if you're going to call in, we have a tech line, to field tech calls. If you're calling Tim or myself, the first thing we're going to ask is, do you have a voltmeter? Because we cannot properly help you diagnose an issue if you don't have a voltmeter. We have all these thresholds built into the system to keep it a balanced system, so we have to be able to read that voltage. Okay, so now I'm going to turn it over to Tim to kind of dive into a little bit of preventative maintenance.
Excellent. Thank you, Jimmy. And again, just as Jimmy mentioned, we do have a fantastic tech line. You can reach out to them, Jimmy, myself, any of the team at Purkeys, and we're more than happy to walk you through some of this while you're out in the field. If you need to FaceTime us or do a video chat, even better, we're happy to help and walk you through the steps. So jumping into the preventative maintenance and, of course, best practices, a lot of this may seem common, or may seem more common sense, but it's stuff that needs to be checked. You could have things that are, cumulatively just wrong enough that it all adds up and creates an issue. Some of the things are just as simple as, is the control box in the front, is it properly mounted and secured? We've seen a number of them that it could be busted up. Someone backed their trailer into the front of the trailer, gets damaged, issues with sealing due to improper torque. Just make sure that everything looks properly mounted, properly secured at the front of the trailer. Here's also a pretty common one that you'll see out there, especially on some of the older trailers, if they've had road calls, service calls. Anyone that's not super familiar with some of the Purkeys systems, they'll start pulling harnesses apart, and a lot of times it won't be remounted properly. We can very commonly see these harnesses get damaged, whether the trailer was dropped too low and it gets backed into with the tractor, pinches that harness. Can cause a lot of phantom issues. So making sure that that harness is secure and keeping an eye out for signs of previous repairs as well. If you're having some oddball issues where you've checked the fuses, the voltages look good, you run power through it, and all of a sudden the voltages don't look good, there could be a damaged wire inside of one of these harnesses. It stinks having to tear it all apart and see what's going on underneath. But a lot of times you just can't guarantee that whatever's underneath these Band-Aids isn't the cause of your issues. Oh, this is a fantastic picture here. Is this from you, Jimmy? This is pretty wild. But as Jimmy mentioned, that 4-conductor harness going from that nose box or the Purkey system at the front back to that charger, that's the lifeline of the charging system. Of course, you have your power and ground in there to send the power back, but also that orange wire that's powering up the controls at the front of the trailer. And even, I would say most importantly, that yellow ignition, that turn-on wire inside of that 4-wire harness. Damage to that harness is going to throw this system into a frenzy. It's not going to work as designed. As Jimmy mentioned, sometimes when it's being installed even, that cut-to-length harness is cut too deep. It'll nick some of the wires and expose that copper. It might work fine for a few years, maybe even half a decade or so, but especially in some of the northern states, those exposed copper wires will start getting green and fuzzy, and you start losing your conductivity through that. You can't flow as much power. So again, just looking for any damage to that harness. It's easy to say it was working fine before, that repair's been in place for years, but it could be something where that repair just finally gave out and issues creep in. So always keep an eye on these. And of course, Jimmy mentioned earlier the 30 amp breaker inside that battery box. Also keep an eye out for the charge plate itself, making sure that that's secure. That's really something that you don't want loose inside of there. Anything loose inside of a battery box is a huge, huge hazard, especially when it's metal, and it could very easily short out on any of the terminals. And we know what happens when you short out a battery. Things get hot very quickly. So even further than the charge plate itself, double check that your batteries are securely mounted. Everything needs to be secure. And speaking of tightness, we've certainly seen it here before where the installer didn't fully tighten the connections back at that charge plate assembly. It's one thing if there's not a tight connection on the smaller wires, your ignition and liftgate positive wire, which any eagle-eyed viewers on this PowerPoint will realize we're missing a wire in this picture. This has no orange wire out of that harness for the liftgate positive. That means that old style selector direct box wouldn't light up or function at all. It's not going to know that liftgate voltage. It's not going to be powered. So something to keep an eye out for there. And of course, talking tightness, specifically on your power and ground input from that 4-conductor harness, you're flowing close to 30 amps through that harness at times. And if those connections are not tight, you're going to cause a lot of heat buildup on that stud. It's going to reduce your charging amperage, but even more importantly, it's going to cause a lot of heat. I've seen it where that positive input stud was never tightened down at all. It was finger tight. You could loosen it by blowing on it. And eventually it ended up melting that stud completely out of the terminal block itself. Were it to short to something, of course, it is fused at 30 amps, so it wouldn't have caused anything major, but loose connections are a huge, huge thing to watch out for. And on our older DC-DC chargers, again, as Jimmy had mentioned, these older chargers are the same footprint as the new chargers, but these older chargers, you can see on the sticker there, this is a Eaton off-the-shelf charger, and the 4-pin Deutsch connector that plugs into there. If you're having issues, that's a quick thing just to unplug and double check. Sometimes those connections can overheat if it's not a good enough connection, or if the seal is damaged on that connection. I believe we have a picture right here of one that very clearly witnesses damage. This is a part, it's a short pigtail harness that we do supply if needed, let us know. This is something that we keep in stock. It's very quick to swap out. One thing to mention, if you're going back a slide here, if your connection looks like this at the Deutsch connector, you can, of course, replace that harness with a new one, but you also need to double check the connection inside that converter as well. If it was looking that bad in the harness, chances are that connection could also have issues inside of that converter. So need to clean it as best as you can. And really, this was kind of the reasons that we switched to our own in-house converter with the flying leads instead of this connection that Eaton was using, was to avoid issues with this 4-pin harness. But it is something that you can upgrade if you've replaced this harness and it still has issues and you think that there's issues with the pins inside of that charger. Replacing the charger might be the best bet at that point. And as Jimmy was mentioning earlier, getting power up to that Purkeys charging system at the front of the trailer, it's all going through this 2-amp fuse. A pretty good picture of it here in the orange circle. There's that 2-amp inline fuse holder. Looks like it's missing a fuse there, but more importantly, even if there was a fuse, if you follow that circuit, it's missing the connection at that terminal block up there, that orange wire that goes through the 4-connector harness up to the liftgate system, the charging system at the front. So keep an eye on that. And again, Jimmy touched on it lightly at the beginning, but just tracing this circuit all the way from the liftgate batteries, getting that power up through the 30-amp breaker here, back to that terminal block and the charge plate assembly, through that 2-amp fuse and up to the Purkeys system at the front of the trailer. This 30-amp breaker is certainly one to inspect as well. And you can, obviously it's a very quick visual inspection to see if the breaker is tripped. A small yellow arm pops out of it. You can reset it, but there's usually a reason why a breaker trips. So that's something you'll want to inspect. And make sure that you're looking at the connections on the back of the breaker as well. It would be extremely rare to see those come loose, but it's something that you can't discount. You do have to double check, make sure that all the connections are tight and proper. And that brings us to poll question number 3. And this one, we'll see how everyone does. We haven't covered it yet. It's upcoming, but we'll see. As far as a best practice for a charging system, we have the question, should the positive and negative wires from the charging system, the Purkeys charging system, be on opposite batteries in the battery box? Your liftgate system has 2 batteries, sometimes 3 batteries, but at least 2 batteries in there. Should your positive and negative from the Purkeys charging system be on opposite batteries in that battery box? And no harm, no foul on this one. Give it your best guess, or if you know the answer, even better. We'll cover it in just a minute here. But it is a general best practice anytime that you have a charging system or discharge going in or out of batteries. And again, this is a yes or no on should charging systems be on opposite batteries. And it looks like we have a pretty good response rate on this one. We'll see how we did. It trips a lot of people up.
No.
The answer is yes. Yeah, anytime that you do have a major power draw or power going in or out of batteries, you do want to stagger those connections. So positive on one battery in that battery bank, and you're going to want to put your ground on the opposite battery at the other side of that battery bank. It really just forces that power to evenly flow through both batteries compared to more or less piggybacking through the jumper harnesses to that secondary battery. So good job. This was a great answer. Thanks for taking the time, guys. Let's keep moving on. I'll work my way up to the next poll question, then hand it back to Jimmy. Again, talking maintenance and best practices. Jimmy, I don't know where you found this picture, but wow. So this would be something that could use a little bit of maintenance and training on best practices. I don't know if they pulled this up from the Titanic or what. You're missing battery hold downs here. It looks like one of the main positive wires coming off of that battery on the left has been repaired. It's missing heat shrink or protection to keep the copper strands from corroding inside of that ring terminal. Big scary thing is the 30 amp breaker in that metal bracket floating around, just waiting to ground out inside of this battery box. This also looks like a older a metal battery box as well. So
yeah,
lots of things to short out on in here. Overall cleanliness too. This thing just needs to be torn apart, cleaned up. If it gets this bad, guys, Purkeys does have a full replacement battery box system ready to bolt on to the trailer. At this point, I'd say start fresh.
Yeah. Plus the mix match batteries.
Yep. Didn't even see that.
Dates.
Gosh. And we talked about loose connections on the Purkeys charge plate assembly. That's a system that typically, we mentioned around 30 amps is going to be the max that you would ever see, usually a little below 30 amps. If you're having loose connections on your batteries themselves, that is a huge, huge concern, especially on a liftgate. You could be pulling close to 200, more than 200 amps, surge amperage, sometimes 500, 600 amps for a quick second. But this is a huge, huge concern, having loose connections on those batteries, specifically in multiple battery setups where you have that jumper wire. If this comes loose all the way and that jumper wire from the positive pops off, shorts out somewhere, there's no fusing, no circuit breakers between that, and things are going to get hot in all the worst ways. And of course, you got the green fuzz. You always watch out for the green fuzz, any oxidation or corrosion on those battery terminals. That's going to greatly impact current carrying capacity of that connection. Keeping these cleaned off, sometimes spraying some kind of a corrosion protectant over that connection after it's been made, all things to help with this. And circling back to that poll question, like we mentioned, anytime that you have a major charging source or discharge from a group of batteries, you do want to stagger those positive and negative connections. It's always going to be the best practice in these scenarios. So something to keep in mind. And really with the Purkeys system on its own, the output from that charger, typically around 20 amps or so, should still be staggered. Not the absolute end of the world if it's not, but anytime that it's really, I'd say that's about the threshold. Anything more than that, you really should always be staggering those connections. And if you see one while you're doing PMs or swapping out batteries, just make sure that you are using that best practice, stagger that positive and ground across the battery bank. And we mentioned it earlier, making sure that everything is tight inside of that battery box. Battery hold downs get a little bit tricky because I know Jimmy and I, being out in the field, have seen a number of battery hold downs completely loose. Huge, huge issue there. If it's loose enough where that hold down bracket can slide back and forth, if you hit one of those positive studs, it's going to throw a lot of sparks and it's not going to stop. But also we've seen it where that battery hold down is over tightened, where it's squashing the tops of the batteries. You don't want to put that much pressure on these batteries. Should not be tightening these down with power tools. Get it nice and tight with your 3/8 ratchet, something by hand. Just make sure that you're not over torquing, under torquing them. And it is a maintenance item. We talk about all of these things. They're not one and done checks. They're things that do need to be checked. Any kind of mechanical connection does need to be double checked for tightness. And another very obvious one is any damage to the batteries themselves. The This is likely going to be caused from poor battery mounting, that battery hold down has an issue, or just poor handling of the battery while it's going in and out of that battery box. It could have been a service call in the dead of night somewhere. They dropped the battery while they were trying to put it in. It's damaged. If you have a battery casing that's damaged, even if it's a brand new battery, that battery needs to be retired. That's not going to be a good thing to have inside of that battery box. And of course, as mentioned here, are they the right type of battery? Are they meeting that spec of what you need? And I believe that we also have a separate webinar on batteries specifically, because that is a whole rabbit hole that you can get stuck in for quite some time. And we love talking about it. And speaking of which, I think I missed it in the picture right here, didn't I, Jimmy? The mismatched batteries here. Certainly something to watch out for. With something as critical as liftgate operation, really should not be mixing and matching battery banks in these units. And finally, even on brand new trailers, there's a lot of things that you do need to watch out for. We'll put it in the preventative maintenance section here because it is things that should be at least visually checked. But wire routing is always something specifically on new builds that you just need to keep an eye out for. We've seen some that are done just impeccably beautifully wire routing, and some where the wire harnesses are zip tied up or hanging down, or as you can see in the very left picture, missing a grommet somewhere that wire may rub through over time from abrasion. Wire termination in that middle picture on the bottom really should not be using nylon insulated ring terminals or nylon crimp terminals anywhere at this point. It's 2025. Heat shrink is affordable. It's great quality. You can see the quality of the crimp underneath. You should really be using uninsulated wire terminals and then sliding heat shrink over it. That way you can visually see that the crimp was made properly, the wires were inserted all the way. Nylon crimp terminals really should be retired altogether. And another thing is making sure that it's the correct size of wire terminals that you're using. Some of our charging wires are 8-gauge wires, and that's not a very common size for a lot of toolkits to have. So we've seen it where people try to jam a 8-gauge wire into a smaller 12 to 10 gauge, as you see here, one of the yellow terminal wires, and they cut off the spare strands. That's going to cause overheating issues. You're going to not flow as much amperage. Making sure that all of the wire connections are proper, huge, huge, huge with the charging system. And of course, we covered torque on all of these connections, especially when you're flowing any amount of amperage through a connection. A loose connection is going to cause issues. And one last thing to mention is if you do have a charging system that has 7-way charging, one of our select systems, or a direct where it's only through the 7-way, that 7-way circuit is often shared with other devices in the system. And sometimes it'll be spec'd with a circuit breaker on the back of your 7-way connection. Sometimes those circuit breakers are spec'd all the way down at 15 amps. I believe you can also spec some of those 7-way circuit breakers at 20 amps, 30 amps, but anything less than 30 amps, you're going to end up having issues with the charging system. If you try pulling 30 amps almost through a 15 amp breaker, that 7-way circuit breaker is going to be popping and resetting almost constantly, and it's going to wear that breaker out. It is a mechanical bimetallic breaker, and eventually it's going to wear that breaker down to where it's not going to function anymore. You're not going to have liftgate charging off of that 7-way source. More importantly, that trailer is not going to have an active ABS anymore. This is the circuit utilized for that, the auxiliary circuit. So making sure that the Purkeys system is at least connected to the unprotected side of that breaker, if it is a lower amperage breaker, is a huge thing to look out for. And it looks like that's bringing us to the next poll question. Get ready to answer. Next poll question: how often should all connections be checked in the battery box? We have A, check all those connections twice a year. B, after any road service has been completed. C, after a driver write-up for liftgate issues. Or D, check all of those connections, all of the above. We'll wait and get a couple of responses on this, see how you guys do. Again, this is just checking those battery connections in the battery box. It should be a pretty quick and easy check. It's fairly accessible most of the time. And how often should you be checking those connections?
All right.
Let's see how we did. Perfect score. Love that. That is, that's exactly right. Anytime that anyone has been inside, you know, especially a road service call, a lot of those guys might not be super familiar with the Purkeys systems, especially if it's a third party where they're out of area for your fleet. If you have your own technicians, should always just be double checking, making sure those connections are tight. The standard 2 times per year is also something great to follow. And of course, if there's any driver write-ups regarding liftgate issues, checking tightness is the first thing to check. If you find loose connections in there, that might be enough to sign off on it, put that trailer back in service after doing a quick test. But it's always good to run through the system and test it after any write-ups as well. And from here, I think it's time to pass it back over to Jimmy. Jimmy, do you want to talk on drivers, driver awareness, driver training, and what they should be looking at?
Absolutely. Thank you, Tim. And apologize, we are going a little bit over time, but I do have a few more things that I think are important to talk about. You know, driver awareness, they are our first line of defense. And there's a lot of things they could do to help prevent, road calls from even happening before they even leave the yard. So I'm going to kind of dive into that really quick. We kind of created this little cheat sheet for them, but they can observe the LEDs. You know, we talked earlier that in order for the indication that the liftgate batteries are getting charged from the tractor or the reefer is the solid green LEDs. So really, that's the first thing. Once they plug in their dual pole, 7-way, or whatnot, make sure the LEDs go solid green before they leave. If if there's anything other than that, blinking amber or orange LEDs, they need to tell someone. They don't typically leave the yard on a half a tank of fuel. Kind of treat it the same way. So LEDs is on the front are key for the driver to pay attention to. And typically the driver is not going to have a whole lot of tools, maybe not. But there are a few things that they can do, without having, all the proper tools. They can look at the DC-DC converter. With the tractor running or the reefer running, it should be solid green, indicating that it's charging liftgate batteries. Moving on to the next thing, if the LED on the DC-DC converter is solid green, check the circuit breaker. We talked about that. Is that little yellow arm flipped down? They can simply reset that breaker. And I put the fuses in here on this section. They may or may not have tools to get inside that box, but could simply be a blown fuse inside the control box. And then inspecting that 2-amp fuse that we talked about that's at the DC-DC converter. So there are some things, again, the drivers, they're our first line of defense. So there are a few things they can do to help prevent this. And we try to spend a lot of time driving trainers, training drivers, can't talk today, when we're out doing, training out in the field. We like to incorporate them because, they're using the equipment. Moving on to the next thing is, repair parts and upgrade kits. Time is money. If you're not stocking anything, for these systems, things happen. Whether a breaker has just gone bad, the control module's gone bad, the DC-DC converter itself. If you don't have those parts on hand, you have to, call in and order them. That takes time, and that's that much time that trailer is down. So we put together these little replacement parts drawers. They're the same drawers that kind of fit in your parts bins, your Imperial bins, and we've got them for various kits, whether it's the direct, the select. We put a lot of the most common parts in these drawers, so that is available to you to be able to kind of decrease that downtime. The next thing is this one's becoming bigger and bigger. It's our battery cleanup kit. Right now, we've only got it designed for one battery box, but we're working to design it for all the different Liftgate battery boxes out there. But it's basically it's intercell connectors that really clean up the inside of that battery box. Keeps people from putting power wires, ground wires, just wherever they want. We give them nice terminal strips to put all the powers and grounds away from the battery, off the battery, onto these junction studs. And you can see in the picture, it just really cleans up that battery box. When you're trying to diagnose a problem and you look inside and you see all these wires going everywhere, it tends to be a little tough to diagnose. So that's why we came up with these cleanup kits. The next thing Tim mentioned earlier is if you have that just old, worn out battery box that it's really not worth putting any effort or money into it. We do offer complete battery box kits, minus the batteries, but with the cleanup cables, the DC-DC converter already mounted in, all in one kit. Again, we'll work to do this for all battery boxes, but that's something we're starting to explore and make that available for everyone. But again, it's all about increasing that uptime. So that brings us to the end of our webinar. If you have any questions, please send them our way. Please stick around. I know we went way over on time, but please stick around for a brief survey at the end. Give us ideas on new webinars you may want to hear about. And so any questions you have, feel free to ask.
Yeah, thanks, Jimmy. And just want to bring up again, this is more or less a very general webinar to cover multiple systems that we have at Purkeys. And of course, we do have a very specific training material that can apply to the systems that you're running at your fleet. I know that we've worked very hard to come up with a lot of great training documentation and things that we can specifically tailor. If you let us know what your issues are that you're seeing with your fleet, it's training things that we can put in place for you.
And I just had a question come in. What is the part number on those repair kits? We'll get those out to you. There's multiple different variations. It would probably take too long to kind of discuss it on this webinar, but we'll make sure and get that out to you. What those part numbers are. Eventually, we'll have a flyer on them, but we're still trying to put it all together. But thank you for the question. All right, I don't see any more questions coming in, so I think we'll call it that. Thank you for joining us today.